So these notes are on harmonic motion. This is actually the introduction or the first part of the notes that lead into waves. So a lot of these terms you'll see repeated when we go over waves, but again, this is the introduction. So harmonic motion. Harmonic motion is repetitive motion, so any type of motion that repeats itself is known as harmonic motion. So the examples here in the notes are rocking a baby to sleep, a rocking chair, a fan going back and forth, the spinning of a wheel, any type of motion that repeats itself, that does the same thing over and over and over and over again, that's known as harmonic motion. Objects that actually perform this type of motion are known as oscillators. So any oscillator is an object that performs harmonic motion or does the same motion over and over and over again. Okay. So you have two different types of motions. You have linear motion and then you have harmonic. So we just said harmonic is the repetitive motion, the same type of motion over and over again, whereas linear motion is just it doing it one particular time. So if you're talking about the spinning of a wheel, it would just be one spin of the wheel or going from the start to the end. Okay, harmonic motion would be that pedal or the wheel turning over and over and over again. Okay, so here they give some more examples. You have the swinging of a pendulum, so I can see the pendulum going back and forth. Okay, that's an example of harmonic motion. Here they're giving an example of somebody riding a bike. Okay, so if he just goes from point A to point B, so let's say he goes from his house to Wesco East High School, that would be linear motion. If he kept going that same route back and forth over and over and over again, that would be an example of harmonic motion. Or the spinning of the wheel, okay, that would be an example of harmonic motion. The wheel keeps going in the same path over and over and over again. Okay, the girl on the swing, that would be an example of harmonic motion. She's repeating the same motion over and over and over again. Okay, so again, harmonic motion is the same motion that keeps repeating itself over and over again. We talked about the difference between linear and harmonic. Okay, a cycle is one complete back and forth motion. So if you're talking about one cycle of a pendulum, if this is where it starts, then one complete back and forth motion, that would be a cycle. If you're talking about the cycle of the spinning of his bicycle wheel, one complete rotation of the wheel, that would be a cycle. If you're talking about the girl on the swing, one complete back and forth motion of her on the swing, that would be one cycle. Okay, where do you find harmonic motion? Again, oscillators are any type of object that performs the same motion over and over and over again. There's a bunch of different types of oscillators naturally that occur, okay, in our world. So you have the Earth-Sun system. So we revolve around the sun. We follow the same path and we keep following that same path over and over and over again. Seasons, okay, is another example of harmonic motion. We follow the same seasons over and over again every year. And then you have music and color. Okay, those are also examples of harmonic motion because we're dealing with waves. So music, sound travels as a wave, and so does color, light travels as a wave as well. Okay, so there's different vocabulary terms that you'll need to be familiar with in terms of both harmonic motion and waves. So those vocabulary terms are period and frequency. Okay, period is the time that it takes for one cycle to occur. Remember, one cycle is one complete back and forth motion. So if you're talking about the swinging of a pendulum, it would be one complete back and forth motion. If you're talking about the spinning of a wheel, it would be one rotation of the wheel. So the period, which we abbreviate with the uppercase letter T, is the time, okay, that it takes to complete that one cycle. Specifically, we're looking at the time in seconds. So period is measured in seconds, and we abbreviate period with the uppercase letter T. And remember, it's the time that it takes, let's say for this pendulum, to make one complete swing, or the time that it takes for the tire to rotate one time around. Okay, frequency is the number of cycles, okay, per second. So some oscillators go really, really, really fast, and you're going to have them completing multiple cycles in a 1 second time period. So how many cycles they complete in a 1 second time period would be the frequency. The example that they're giving here is your heartbeat. Okay, your heart will beat 2 complete times, 1.5 to 2 cycles per second. So you're going to have a beating of your heart. It's going to complete a cycle 1.5 to 2 cycles every single second. Okay, we measure frequency in the unit of hertz. And then I didn't put it here, but we abbreviate frequency with the lowercase, the italicized or the lowercase letter f. Okay, here are two other words. So amplitude. Okay, amplitude is the size of the cycle, how big or how much energy that particular oscillator is carrying. So if you're looking at the swinging of a pendulum, okay, the distance from its equilibrium, so here's the equilibrium, this is when there's no energy flowing through the pendulum. Once you start pushing or moving the pendulum, it's going to start to move from side to side. The stronger or the more energy you put into swinging the pendulum, the further away it's going to move from its midpoint or from its equilibrium. That distance here is known as the amplitude. Okay, here, if you're looking at a wave, okay, here would be the equilibrium point. This is when no energy is flowing through the wave. It would just be a straight line. But once energy starts flowing through the wave, it's going to start to move up and down. How far away it moves from its equilibrium point, that would be the amplitude. The further away it travels from its midpoint or from its equilibrium, the more energy, the bigger the amplitude that particular wave is going to have. So this particular amplitude is a lot smaller than compared to this one. Okay. Then you also have damping. So damping is specifically for pendulums. Okay, so if you were to push on the pendulum, it would start to swing back and forth, and over time, if you were to stop pushing on the pendulum or you didn't continue to add energy, that pendulum would stop moving, or it would slow down. The amplitude would decrease until it eventually stopped. The reason that it's doing that is because of friction with the air. So you push on the pendulum, it starts to move, and then because of friction with the air, the amplitude will get smaller and smaller and smaller until there's no energy and the pendulum has stopped completely moving. Okay, there's some formulas that go along with formulas that go along with making these calculations. So here's the formulas. You have the formula to solve for the period, and then you have your formula to solve for the frequency. Remember, period is the time that it takes for one cycle to occur, and then the frequency is the number of cycles per second. You can see that they are inversely related. Okay, the longer the period it takes, so the longer it takes to complete one cycle, the less cycles you're going to have in a 1 second time period. So they are inversely related. So let's look at this first problem. First problem says the period, the time that it takes to complete one cycle, is 15 minutes. Let's say you're talking about the spinning of a wheel. It takes 15 minutes for that wheel to make one complete cycle. They want to know how many cycles per second would you expect, okay, or the frequency. So remember, frequency is 1 divided by the period, okay. Remember, you need to your period needs to be in seconds, so I need to convert 15 minutes, to seconds. So it would be 15 times 60 for a total of 900 seconds. So you have 900 is the period. And you'd use this formula to solve for the frequency. So frequency is 1 divided by the period. So 1 divided by 900 seconds would give you a frequency of 0.001 hertz, because hertz is the unit that we use to measure frequency. So go ahead and solve for problem 2 and problem 3. Just remember that period is the time it takes to complete one cycle, but we need to have that in seconds. So if it's in minutes or in any other unit, you would need to convert that period to seconds. Okay. So graphs of harmonic motion, just remember, okay, here you have the pendulum, and then here you have the wave. So remember, if I wanted to measure the amplitude, remember, amplitude is the distance from the equilibrium. So for a wave that moves like this, here would be the equilibrium. The distance either up this way or down this way, that would be the amplitude. So in this case, it goes up to 20 centimeters. So the amplitude for this particular wave would be 20 centimeters. If I were to measure, so here's my equilibrium point for the pendulum, how far out the pendulum goes, it goes 20 centimeters out to the side. So again, the amplitude would be 20 centimeters. In terms of measuring one cycle, so if you're looking at a wave like this, okay, you have different parts of the wave. So here you have the crest, that's the top part of the wave. Here you have the trough. One cycle, okay, or would be from crest to crest or from trough to trough. So if I were to actually measure the length of my cycle, okay, it would be the length from this point to this point. And then they're telling you, remember, the period is the time it takes to complete one cycle. So if this is one cycle, you're looking at how long it's taking, in this case it's 1.5 seconds, to complete this one cycle. Okay. So again, we're not going to be worrying about the calculating the amplitude. Just know how to read the amplitude. So remember, amplitude is the height from, or how far out it goes from its equilibrium point. Okay. And then remember, the period is the time it takes to complete one cycle. So if I was looking at a cycle, it would be from crest to crest or from trough to trough, the time it takes to do that. Okay. Here are your formulas. Remember, period is the time it takes to complete one cycle, and you always need to have that in seconds. So don't forget to go ahead and answer these questions in your Edpuzzle notes.